Hello, Ifriki here. I'd like to talk about putting together a satellite, an actual satellite, spacecraft, the hard and software that you send to space, and who does it, what kind of team is needed, and what kind of expertise is needed. Basically, if I compare it again to your smartphone, well, bearing in mind that your smartphone by itself can constitute a full-on spacecraft, right? If you send it to space, barring the space environment, it is capable of doing a decent job. You may need to modify a few things, but basically your phone as it stands can be a spacecraft. But comparing to your phone, you have key subsystems. You have key parts to a satellite. To build a satellite, you will need the payload, whatever it is. If I take the example of taking images of Earth, then you will need a camera. If you want to take images of Earth from space, you'll need a camera. You choose the camera depending on the resolution you're looking for, right? Now, if you have a smartphone, chances are there's a camera on it. And this camera is not hanging in mid-air, right? There is a set of hardware and software that supports this camera. Similarly, on the satellite to take images of Earth, you will have a camera on board. So you would need whoever is the guy who's the specialist of that particular camera. If it's something you buy, you will need at least the datasheet to understand. So there's the payload. If it is some fancy new kind of camera that needs to be designed from scratch, you will need the expert of this camera, to work with you. The payload specialist. Now, once you have that, this camera will need power. The rest of the spacecraft will also need power, so you will need someone who knows how to ensure that there is enough power on board to get the job done. On your smartphone, there is a battery. There's a battery to store energy, and if you want to recharge the battery, you plug in your phone, right? And we know we have now solar chargers now in different shops here and there. Similarly, on the spacecraft, you will need power. There are batteries on the spacecraft. Yes, you do have batteries. In fact, you have batteries that are not so different from the batteries that you have in your phone. And these are for, at least when it comes to nanosatellites, CubeSats, 1U, 2U, 3U, things that are not bigger than this, yay. How do I put it? And these batteries are charged with solar panels, so you will have solar panels on the satellite to always charge the battery and make sure there's enough power on board to do what needs to be done. Now, who decides how many solar panels, what kind of batteries, and charge-discharge cycles? You have the power systems engineer to do that. So there's someone who should understand how to power an entire system. So if you are a power systems engineer or power engineer, maybe not in the space industry, but if this is your game, you could find a place in the space industry building satellites, right? That's power. Then you need, just like you have the operating system on your phone and different softwares running to run different parts of your phone, including the camera, you will need flight software, on an onboard computer. Someone basically to program the brain of the satellite. You'll need that software engineer. It's generally an embedded systems engineer. So if you are into embedded systems, you have a place in the space industry, right? Writing software, if you know software engineering, you know how to engineer a piece of software to do some tasks. If you know how to write an algorithm is an algorithm. You implement the algorithm in one code or the other. So if you know how to write, how to design an algorithm, and if you know how to encode this algorithm, you can find a place in the space industry, because this is one of the things that needs to be done. You need communication. And communication, what does it mean? It means you need to be able to transmit information from Earth to the satellite in orbit, commands and so on and so forth, and you need the data. This camera will take images. You need to send the images down to Earth. For that, you need to have all the hardware and software necessary for a communication link to be established. Now, on your phone, you do have antennas and software and hardware, your RF link, your RF chain, RF chain, that ensures that you can communicate wirelessly on your smartphone. You also need your RF chain. What is the RF chain? It's the set of hardware that ensures that your RF communication, radio frequency communication, can indeed occur as per your design. You need the antenna design that works for you. So the same thing, basically. Whatever ensures that you can communicate wirelessly on your smartphone, you have similar systems on your satellite. So if you are an RF engineer, if you're an antenna designer, and if you are on the hardware and or the software part of this, you do have a place in the space industry. You can find yourself in a team building satellites. The mechanical structure of your phone was designed by somebody who's good at mechanical design, strength of materials, and structural integrity, and stress testing and all that. Similarly, the mechanical design of the satellite needs to be designed and implemented. So if you're a mechanical engineer, you have a place in the space industry. You see, to put together a satellite, you need a whole lot of different specialties working together as a team, right? And now, if there's going to be some propulsion on the satellite, you also need someone who knows how to look after propulsion. If you're looking at orientation, we're talking about taking pictures. So if your phone, if you're going to take a picture, you will have it landscape, portrait, whatever. If it's for a selfie, also, there is a subsystem called attitude determination and control system on a satellite that makes sure it's always oriented and pointing towards where you want it to be pointing. And there is an ADCS specialist for that. This is one of those fields where you need to be great at control systems, engineering, and you need to understand a great deal of orbital mechanics, mechanics in general, and then orbital mechanics to fill this kind of position. Of course, software design, hardware design. It's more of a demanding task. It is one of those that can be seen as specific to space. But this is one thing that you can also look forward to doing. I just wanted to share these few things with you, so you know that wherever you are on this spectrum, you can find a place in space. Bye bye. Talk to you later.